Lesson 47, circles and inscribed angles. Previously we've done central angles, and this kind of goes along with central angles. So when we had two radius, we knew that this angle here was called a central angle, and it was the same measure as its arc. So if this measure was 50, this angle was also 50. Now what we're going to do is look at inscribed angles. Inscribed angles the definition of an inscribed angle is an angle whose vertex is on the circle. Here's the vertex on the circle. And whose sides contain chords of the circle. So if you remember, a chord is a line segment in a circle that goes to two endpoints on the circle. So we have vertex and we have two chords. Don't go through the diameter here. That's just kind of a more specific chord. But the measure of PRQ, the measure of the inscribed angle, is always going to be half of its intercepting arc. And remember, intercepted arc means basically what is in between the two chords here. This is the intercepting arc. So if this angle was 50, that would mean the intercepting arc would be 100. And that's all it is. That's all an inscribed angle is. And one quick thing, it gives theorem 47-2, but it's pretty self-explanatory. If an inscribed angle intercepts a semicircle, then it is a right angle. So a semicircle, in order to have that, you have to have a diameter. So here's our diameter. Well, it actually still goes along with the inscribed angle rules. We know that this measure would be 180 degrees, right? A line is 180. And if this is our inscribed angle, it'd be half of 180. So we would always know that it'd be right angle. And that's all that theorem says. Now let's look at an example problem. Example 1a first wants us to identify the inscribed angle. Well, make sure you label it as, don't just label it as K, label it as JKL or LKJ. Either would work. But that is the inscribed angles labeled. Now what's to know the arc intercepted by an angle JKL? Well, its arc intercepted would be arc JL. And you put the little arc sign above it. There's intercepted arc. And then finally it wants to know the measure of angle JKL. Well, we know JML is 52. How can we go from here to angle JKL? JML is a central angle, so remember, central angles are always the length of the same length of the arc. And so if this is 52, we know JKL is half of that. So 1/2 of 52 would be 26 degrees. So therefore, an inscribed angle is half of a central angle. Moving on, looking at example 3, it gives us all this diagram, and it wants us to find angle XYZ. First, let's go ahead and locate XYZ. I'm going to highlight over it here. This is the angle we're trying to find. So we actually know that XYZ has a value of 2c plus 9. That is a 9. 2c plus 9. We also see this 3c degrees here for angle XAZ. Well, here's something interesting to note. What I want you to see, and this is a theorem, but I'm just going to show you, what I want you to see is that angle XAZ is actually intercepting the same arc. The arc this is intercepting is XZ. But the arc that XYZ is also intercepting is XZ. So what that means is that their inscribed angles are actually the same. So since these are congruent, we can say 2c plus 9 equals 3c, and then solve. Subtract 2c, they make it easy on us. C equals 9. Now that's the measure of c, but it wants to find x, y, z. So you could actually plug in c to this angle, or up here, you would get the same answer. 9 times 2 is 18 plus 9, 27. Or 3 times 9 is 27 degrees. So there's the measure of angle XYZ. But when you have two angles that intercept the same arc, they are congruent. Last thing we're going to look at is an inscribed quadrilateral. An inscribed quadrilateral is quadrilateral inside of a circle. So its endpoints lie inside of a circle. And in this, it wants us to find measure of angle U. In order to, the theorem 47.4 states that opposite angles in a inscribed quadrilateral, opposite angles in inscribed quadrilateral are actually supplementary. So they add up to be 180 degrees. So therefore, T and V would add up to be 180, and then S and U. So I can say 4Z is supposed to be a Z. 4Z plus 3Z plus 5 equals 180 degrees. And then we solve for Z. 4Z and 3Z, 7Z plus 5 equals 180. Subtract 5. Whoa. I'm ahead of myself. 175 equals 7Z. This is becoming scribble scrabble. So divide by 7. And for 175 divided by 7, you would get, oops, put it wrong in my calculator. You would get 25. So 25 would be, actually, sorry, 25 would be Z. But it wants to find the measure of angle U, so we got to simply plug it in here. 25 times 3 plus 5. So 75 plus 5, 80 degrees would be your angle for U. And that's how you do inscribed quadrilaterals. Opposite sides, or opposite angles, are supplementary. And that is the end of lesson 47.